All right, let's look at exponent properties as a review for things that we should know about exponents, and if we don't, we're going to learn them the first time and we're going to use them a whole lot. So the first two we're going to look at are the zero exponent. Any number raised to the zero power is equal to 1. That's the answer. Okay, so anything to zero, 4 to the 0, 1. 2500 to the 0, 1. X squared plus 3x plus 7, all to the 0, 1. Doesn't matter what the thing is. If it's to the 0, it's a 1. A tough one to understand is the negative exponent. Negative exponents indicate a reciprocation. Do the reciprocal. Or flip it over. I like to think of it as just moving below or above the divide line. Okay, so like when we have a to the negative n, I imagine there's already a divide line here, and that a is going to move to the bottom, and then the n becomes positive. Okay, likewise the other direction, if it's already on the bottom, it's going to move to the top and become positive. Of course, as long as a is not equal to 0, because can't have a 0 base in the bottom. But for example, 3 to the negative 2, there's the line, we're going to move it down, so it actually becomes 1 over 3. Remember, this it always could be 1 times 3 to the negative 2, and we drop it to the bottom. Or, this 4 needs to go up, becomes 4 to the third. Okay, all examples of negative exponents. Those will come in handy here in a little while whenever we simplify exponents. Product-like bases. To multiply powers with the same base, you add the exponents and keep the common base. So if we have a and they're multiplying, all we do is add the exponents, and a stays the same. So here we have 2 to the third times 2 to the second. That becomes 2 to the 3 plus 2, which is 2 to the fifth. And then if it's a number, you can actually simplify it, because you can do 2 to the fifth. 2 times 2 times 2 times 2 times 2, 4, 8, 16, 32. Okay. To divide powers with the same base, you subtract the exponents and you keep the common base. So when they're in multiply, you add them. Similar type functions, multiply and add, make things bigger. And when they're in quotient, when they're dividing, you're going to subtract them. Remember, this is a negative, so if we moved it to the top, it would actually be a to the negative n. And when it's the same base, you're going to add those. And if you add a negative, it's like subtraction. So I just take and subtract. So if we have 3 to the fifth over 3 to the third, that becomes 3 to the 5 minus 3, or 3 to the second. Now, if it was reversed, if it was 3 to the third over 3 to the fifth, it's technically 3 to the 3 minus 5, which is 3 to the negative 2, which then reciprocates and becomes 1 over 3 squared. Okay, and we could even turn that into 1 over 9, like this should end up being 9 here. But the way that I think of it is, which one of the 3 to the third and 3 to the fifth is bigger? Well, the 5's bigger, so I know it's going to end up on the bottom. So I'm going to drop the 3 from the top, and I'm just going to do 5 minus 3 on the bottom, and it becomes 3 squared. And that's just how I like to think of it. Power to a power. To raise a power to a power, you keep the base and multiply the exponents. So when we have a to the m to the n, that becomes a multiply in between there, and it's to the mn. So 2 to the second to the third. You could do 2 to the second, fourth, and do 4, and then 4 to the third. You can always do inside the parentheses first. That's PEMDAS. But sometimes it doesn't work, or it's easier to multiply the exponents together. Get 2 to the sixth. Product to a power. To raise a product to a power, raise each factor to the power. So product is they're multiplying. So we have an a times a b here, and it's a times b to the m. We can actually separate that into a to the m times b to the m. You can also reverse that process. If we had things that have matching exponents, we can then bring them together inside the same parenthesis multiplying to one exponent. Like we can reverse this back to 2 times 3 squared because they both have the 2. It goes both ways. Quotient to a power. To raise a quotient to a power, raise the numerator and the denominator to the power. So we have a division inside the parentheses. It's almost like distribute, like this is a 1 and that's a 1 and it's power to a power. And so a to the first to the n, 1 times n is n. B to the first to the n is 1 times n is n, so you can separate them. You can also rejoin them if you want to. We could always go backwards, back to this. Okay. And then lastly, the rational exponent. Ratio, or radicals, and exponents are inverses of each other. Okay. The numerator of a fraction, this is where the rational part, right? Rational is a ratio, an a over a b. Okay, a over b. Or x over y. Something divided by something. Ratio. Okay. The top number, the numerator, is your exponent. And the bottom number, the denominator, is your radical index. Okay. So the y goes out. It should be inside this piece. And the exponent goes inside. You can actually go in or out. It doesn't really matter. So I don't like the way this is done. The 3 is in the wrong spot. It should be right there. Should be inside that hook. Okay, so if we have 2 to the 2/3, we can make that 2 squared and do the cube root. Or we can make it the cube root of 2 squared. You can go in or out with the exponent part. It doesn't actually matter. All right, now what I'd like to do is try one or two each of all of these on the page here, per page. Sorry about the yawn there. All right, we have to be particular about this. It's -2 squared, which means -2 times -2. Negative makes positive. 2 times 2 is 4. -6 cubed, odd exponents are going to end like they start. Even exponents are always going to be positive of whatever thing it is. Now, if there's a negative on the outside, after we do the exponent, then we have to do the multiply. But here it's going to be negative, and then 6 times 6 is 36. Times 6 is 6, 36, 18, 19, 20, 21. So it'd be -216. Just like that. So be careful about where the negative is or is not. Okay. Evaluate the exponents. Now we've just got negative exponents involved. Well, remember, there's like a line here. We're going to drop to the bottom. So that's technically 1 over 3 to the 3rd. So that's 1 over 27. Okay, so watch out for those. If it's a negative exponent, it's going to drop to the other side. Okay, so be careful with those. Here we've got just 9 squared. Well, 9 squared, 81. Just like that. Now, what happens when we multiply? Well, number times number, so 8 times 9 is going to be 72. And then h has the same base, and what we do is we add the exponents. Well, this is a 1, and that's a -2, so that becomes h to the -1, but there's a divide line. I should drop it, so it should be 72 over h. Okay, and all these are different. I'll try one like 8 here in a second, but look, we got a 5 and a 4. That's going to be 20. C and C. 2 minus 4 is c to the -2, and then we've got h to the 3rd. Well, that c needs to drop, so it's 20 h to the 3rd over c squared. When you drop the c to the other side of the divide line, do the reciprocal, the exponent becomes positive. Notice here we have 1/3 and 1/3 and 1/3. They're all multiplying together. So it's 1/3 to the 4 plus 2 plus 3. So 6, 7, 8, 9th. Now 1 over, let's see, 3 to the 9th. 19,683. 19,683. Just like that. I would accept this piece right here as well. Okay. Exponents and division. With division, we subtract. So 5 minus 2 becomes 7 to the 3rd. which is 49 times 7, so 40, no, clear. X, 49 times 7, 343. Just like that. That's 1. The bigger thing's on the bottom, so I know it's going to end up with r on the bottom. 6 minus 1 is 5. Works just like that. Now let's look at a stacked piece, right? We got 9 over 3. That's going to be a 3 on top. The fifth is up, so b is going to be on top. 5 minus 1 is 4. R, the 4 is on top. R is going to stay on top. 4 minus 2 is 2. So 3b to the 4th r squared. And it works just like that. Here we got a little bit of both, okay? The 5 is going to stay on the bottom. Now, this is not bigger. It's negative. And if we subtract negative, we should actually move it up. And 5 plus 1 makes h to the 6th. This is negative. It should move up. C plus 1 and 4 should be c to the 5th, just like that. Oh, I skipped number 1. 9 times 5 is 45. B times B, B to the 1st and S, so B to the 4th. W to the 5th, W to the 4th, W to the 9th. It goes just like that. Watch out for those negatives. Remember, like on 3, this is already negative, so it's going to drop down and join the 2 down there. So it's going to be r to the 8th on the bottom. This is negative. It's going to go up. That's going to be into the 8th on the top. And 9 and 2 don't divide. So we're stuck just like that. Okay, now we're raising powers, 2 powers. So the 3 goes to everybody. So it becomes 3 to the 3rd. Z to the 2 times 3 is 6th. Z to the 2 times 3 is 6. These are like. So that becomes 27. That's 3 to the 3rd. Z to the 6 plus 6 is 12th. Just like that. C, C, C. So it's 2c to the 1 plus 2 makes 5 to the 3rd. So that's 2 to the 3rd, c to the 15th, because we multiply them. And 2 to the 3rd is 8c to the 15th. Got to simplify it all the way. Okay, just like that. Now we're mixing everything together. I do the inside first. These are going to subtract. That becomes 7 to the 4th. To the 2nd, so that's 7 to the 8th. And if I really wanted to find out what that was, 7, a to the b, and then 8th. Let's see, 5,764,801. This is good enough. Okay, oop, that's not what I wanted. Drag it back here and go that way. There we go. All right, I'm going to do this. 5's bigger, so it becomes g to the 3rd, which is just g to the 3rd. We don't have to distribute first. We can subtract to make it simpler, smaller, then do that distribute the exponent into both the top and the bottom. Okay. Now we're just doing mix all of it. 3 times 2 is 6. H and H, 3 plus 3 makes h to the 9th. It's all squared. So that becomes 6 squared times h to the 18th, and which is 36, h to the 18th, just like that. I'll do a divide one as well. That's 8 to the 1st and 8 to the 2nd. I just go ahead and subtract those and get it 8 to the 3rd, which should be whatever, 64. 8 to the 3rd, 512 it is. The small ones we can do, the big millions and stuff like that, just leave it as the simplified exponent. Putting them all together. See, that's a 1. We're going to go 5 squared, squared. That's 5 to the 4th. 5 to the 4th. 625. Just like that. Now here's a fun one. We got these. Let's see. The 3 is bigger. The 4 is bigger. So it's going to end up with a 1 on top. 5. 3 minus 1 is 2. 4 minus 1 is, that's s to the 3rd. To the 3rd. So that becomes 1 to the 3rd over 5 to the 3rd, y to the 6th, s to the 9th. So that's 1 over 125 y6 s9. Just like that. Just apply the properties. All right. Now we want to do it where we plug in something for the n. So we got a function, h of n. It doesn't mean anything. That's basically y, and this is basically x, and that's basically x. You can think of them that way. Okay. So h of n equals 7 times this to the negative 3. 7 times 6 over 5 to the negative 3. Now remember, the negative exponent means reciprocal. So that's going to be 7 times 5, 6 to the third positively. Now we don't do the 7 times yet, we do the exponent. Okay, so that's going to be 7 times 125 over, I don't even know, 6 to the third, 6 to the third is 216. Now let's do times 7. So that would be 1512, just like... Stop doing that. Okay. Now I'm fighting my iPad. There we go. All right, so we got 1/2 times 2/3 to the y. Y is a negative 2, so h of y. Actually, it should have been h of y, or h of n on that one, I guess. Equals 1/2 times 2/3 to the negative 2. So that's 1/2 times 3 over 2 squared. Now these have the same base. We can't multiply them yet. We got to do the exponent. So that becomes 1/2 times 9 over 4. So h of y equals 9 over 8. Just like that. Let's plug it in, do what it says. Follow the orders of operation, PEMDAS. Do what's in the parentheses first, make it smaller. Do the exponent. Sometimes do the exponent into the parentheses makes more sense. You just got to kind of feel it. And that's all.